All right, so we are on part E now, and we want to ask ourselves, are the matrices A and B equivalent or equal? And the answer is no, because all of the entries need to be the same. And as we discussed previously, A33, which is equal to 3, and B33 is equal to 4. So since A33 does not equal B33, the two matrices are not equal. All right, let's move on. So it turns out that there's actually two types of multiplication when you are talking about multiplication with matrices. And the first kind of multiplication that you deal with is called scalar multiplication. So multiplying a matrix by a real number called a scalar results in a matrix in which each entry of the original matrix is multiplied by the real number. So that's another way of saying, like, if you were to define a matrix A as, this matrix with its values A11, A12, A21, and A22, and C is some scalar, which basically just represents some number. It could be 4, it could be 17, it could be -9, it could be 1/2. Then C times A is equal to, what you do is you just take all of the entries and multiply it by C. Okay? So let's look at an example. So it says, consider the matrix A. Note that it is a 2 by 3 matrix because there are 2 rows and 3 columns. And the first part of the question wants us to find A transpose. So notice this has nothing to do with scalar multiplication. It just wants us to find the transpose. And another thing that you'll notice is because this is not a square matrix, if we switch the columns and rows, what that means is that A transpose is going to become a 3 by 2 matrix because we're switching the rows and the columns. So our A transpose will be a matrix with 3 rows and 2 columns. So I'm going to use brackets this time, and we'll write it like this. So our first row contains the numbers 3, 1, 2. So for our transpose matrix, then our first column will contain the values 3, 1, 2, and then our second column will contain the values 2, 1, 0. So that is A transpose there. So let me box that to emphasize our answer. And the second part of the question asks us to find -2 times A. So this is an example of scalar multiplication because we are multiplying a matrix by just some real number. And the way that we're going to do that is we're going to multiply every element or entry of A by -2. So if we multiply every entry by -2, that will give us -6, -2, -4, -4, -2, and 0. So that will be our resulting matrix there. All right, so the other type of multiplication we can talk about is matrix multiplication. And multiplying matrices together is not an intuitive process. First off, matrix multiplication is not commutative. If you don't remember what the word commutative means from algebra, well, you know how 7 times 5 is equal to 5 times 7? If you have two matrices A and B, in most cases, A times B does not equal B times A. The other thing to consider when multiplying matrices is that you can only multiply them together if they are a certain dimension in relation to each other. the requirement is that the number of columns in the first matrix has to be equivalent to the number of rows in the second matrix. Let's look at an example. So example 3 says, consider the following matrices. A, which is a 3 by 2 matrix with the entries 3, 4, 0, 2, -1, 5. And then capital B is a 2 by 4 matrix because it has 2 rows and 4 columns, and the entries from left to right are A, B, C, D, E, F, G, and the last entry is H. So the example is wanting us to multiply A times B and B times A if they exist. Now, let's look at A times B first. Remember that the number of columns in the first matrix needs to be equal to the number of rows in the second matrix. And the way that I usually have students do this is I have them next to each other, write out the dimensions of both of the matrices, and if the inner two numbers are the same, then we are able to do matrix multiplication. So since the inner two numbers are both 2, we will be able to multiply these matrices together. And the resulting matrix is going to be whatever the outer numbers are. So in this case, if we multiply A times B together, that resulting matrix is going to be a 3 by 4 matrix. So let's jump into it and I will show you how to do that multiplication. And again, it's not the most intuitive because you're looking at these two things and you're like, how on earth are we going to multiply those together? Well, let me show you. So A times B is equal to, I told you that it's going to be a 3 by 4 matrix. So there will be 3 rows and 4 columns. So what we're going to do is the very first entry of the AB matrix or A times B matrix, the very first entry is going to be found using the first row of matrix A and the first column of matrix B. And so what we're going to do is we are going to multiply this value and this value. So A11 and B11. So if we multiply those together, that would be 3 times A or just 3A. And then we're still dealing with that same row and column. Then we're going to add the product of 4 and E. So plus 4E, and that's how we will do that. So now to get the value of so that was basically AB11 because it's like the first row and first column in that multiplied matrix. So then to figure out the value that would go in the first row, second column, is we would look at this here and this here. So basically the first row in matrix A and then the second column in matrix B. And we would do a similar thing where we would multiply 3 times B. So it's going to be 3B plus 4 times F. So 4F, like that. I'm going to have to make my matrix bigger, so let me erase that and maybe put that out here. Okay, to get the next entry, we're going to use the first row in matrix A and now the third column in matrix B. And so same pattern, we're going to do 3 times C plus 4 times G. And the reason that I'm using letter values in matrix B is so that you'll see easier what's being multiplied together. If if these were numbers, like C and G, if they were numbers, then that value there would just be a numeric value, so it wouldn't be as clear to see what's being multiplied together. Okay, and then to get the last column value in row 1 of the A times B matrix, we would use the first row in matrix A, and we would use the last column in matrix B. And so that would be 3D plus 4H. All right, I know this is super exciting stuff. Okay, so now to get the value in our multiplied matrix in the second row, first column, what we would do is we would use the second row in matrix A and the first column in matrix B. So 0 times A is 0, so I'll put 0. Actually, I'll put 0A so you can see what's being multiplied, plus 2E. And then if we want to get the second row, second column value, we would use the second row in matrix A and the second column in matrix B, and then we would multiply those so that'd be 0b plus 2f. Now, here's what I'm going to do. I'm going to go ahead and fill out the rest of the values very quickly. My suggestion is that you pause the video here and see if you can figure out what the rest of the values are, and I will input the rest of them in just one moment. All right, so I've gone ahead and filled out the rest of the matrix. So this is our multiplied matrix here. Now, my suggestion is that there are a lot of examples that you can find out on the internet if you just Google like multiplying matrices. My suggestion to you is I would practice more where your second matrix actually has numerical values in it. Again, I used variables to kind of illustrate and hopefully better show what is being multiplied together. So again, my suggestion, I would get some more practice in on the homework, and then if you want more practice, maybe just Google multiplying matrices, and I'm sure a lot of different examples for that will appear. The second part of the question asks us to find B times A if it exists. So let's write out B is a 2 by 4 matrix, and A is a 3 by 2 matrix. So notice that the inner parts do not match. Since 4 and 3 are not the same number, we cannot multiply them together that way. So B times A does not exist. So that would be our answer for that part there.